Hello Year 10 5.3 Mathematics students. Today we are continuing on with the topic of probability and we're learning about using arrays for two-step experiments. So some experiments involve two steps such as tossing two coins, rolling two dice, tossing a coin once and rolling a dice once, or choosing two chocolates from a box. Let's have a little go at investigating this. Two special prizes are to be awarded in some way to Bill, Mary and Lily for their efforts in helping at the school fete. This table/array shows how the prizes might be awarded. Part A, complete the table to show how the two prizes can be awarded. So you'll see in our table we have our first prize here and we have our second prize here. For our first prize we have Bill, Mary and Lily can win it. And for our second prize we have Bill, Mary or Lily can win it. So then we have here that Bill and Bill would win the first prize and the second prize. Then we'd have Mary will win one and then Bill. Then we'd have Lily and Bill. Here we have Bill and Mary. So our next one down here is going to be Bill and Lily. Then we have Mary and Mary. And then we have Mary and Lily. We then have over here Lily and Mary, and then we have Lily and Lily. So does the table show that the same person can be awarded both prizes? So yes, the table shows this because we have Bill and Bill over here. We have Bill and Bill, we have Mary and Mary, and we have Lily and Lily. So what is the probability that Bill and Lily are both awarded a prize? So if we have a look, so for Bill and Lily to both be awarded a prize, we'd need the Lily and Bills to be here. So there is 2 times that Lily and Bill award a prize. So the probability of Billy and Lily, or Bill and Lily, is 2 over a total of 9. So how would the table change if the same person could not be awarded both prizes? So the table would change because these ones here would not be in there anymore. So there would only be 6 possible outcomes. So it would take out 3 outcomes. So there would only be a total of 6. So an array is a table that can be used to list the sample space for two-step experiments. In two-step experiments, the first item chosen can be chosen again. This is called with replacement. If replacement is allowed, then the outcomes from each section can be repeated. If selections are made without replacement, then outcomes from each section cannot be repeated. For example, 2 selections are made from the digits 1, 2, and 3. So with replacement, we have the double ups. And without replacement, we do not have the double ups. We have less outcomes. Let's have a look at some examples. So a 6-sided dice is rolled twice. List the outcomes using an array. So we have the array drawn up for us here already. So what we know about arrays is that we write our first roll in the first column, or first, and then our second roll. So this one here is going to be the spot 1, 1. Then this will be 2, 1, 3, 1, 4, 1, 5, 1. And 6, 1. So we do our first roll first and then our second roll second. And then we continue with this on. So this will be 1, 2. This will be 1, 3. This will be 1, 4. This is 1, 5. And this is 1, 6. So they're all the different types of rolls we can have. Then we have 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. We have 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. We then have 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. We have 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and finally we have 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So state the total number of outcomes. So we have 6 by 6 outcomes, so that means that we have 36 total outcomes. So then we want to find the probability of obtaining the outcome 1, 5. So the outcome 1, 5, so the probability of 1, 5, 1, 5 occurs here, and it occurs here only. You might be thinking, oh, but we have 5, 1 here, but they're not the same. We want the 1 to roll first and then the 5. So there's only one outcome, so it's 1 out of our total of 36. Now we want to find the probability of a double. So a double would be like rolling a 1, 1, a 2, 2, a 3, 3, a 4, 4, a 5, 5, and a 6, 6. And so there is 6 of those out of our total of 36 rolls or outcomes. So that equals 1 over 6. Now we want to find the sum of at least 10. So that means we want our outcomes to have sum over 10. So let's just go in and write our sums in quickly. This has a sum of 12, 11, 10, 9, 8, 7, 6, 7, 8, 9, 10, 11, 10, 9, 8, 7, 6, 5, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, and 2, 3, 4, 5, 6, and 7. So the outcomes that have a sum of at least 10 is this one here, 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 and this one here. So there's only 1, 2, 3, 4, 5, 6 of those. So the sum of at least 10 is going to be 6 over 36, which again equals 1 over 6. Now we want the sum to not equal 7. So we're going to, when we want it to be not equal to something, this is finding the complement of the event. So we go 1 minus the probability of 7, which equals 1 minus the probability of it summing to be 7. So we have a 7 here, 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 and here. So that occurs 6 times. So it's going to be 1 minus 6 over 36. So that is equal to 30 over 36, which equals 5 over 6. Okay, moving on to example 2. So we have 2 letters are chosen from the word kick without replacement. This means that we don't put the letter back in. So we want to construct a table, an array/table to list the sample space. So that means we can't have a K and a K for the first one. So that does not exist. It also means that our I and our I will not exist. Our C and our C will not exist. And our K and our K will not exist here. So we can have our first one to be a K with our second letter to be an I. Our first one to be a K with our second letter to be a C, or our first letter to be a K and our last letter or our second letter to be a K. So because there is the double up of the K, this will occur. Then we could have our first to be an I, our second to be a K, our first to be an I, our second to be a C, our first to be an I, our second to be a K. We could have our first to be a C, our second to be a K, our first to be a C, our second to be an I, our first to be a C, our second to be a K, and we could have our first to be our K, our second to be a K. We could have our first to be a K, our second to be an I, and our first to be a K and our second to be a C. So just remember that our first here is the first number, or first letter, sorry, in each of the samples, and our second is our second letters here. Okay, so we want to now, for part B, find the probability of obtaining the outcome KC. So the outcome KC occurs here, and it also occurs here. So because we have the double K, it occurs twice. So the probability of KC is going to be 2 over, we have a total number of 12 here, so it's 2 over 12, which is equal to 1 over 6. Now, to find the probability of selecting 2 Ks, that's where we have our KK. So we have our KK here and our KK here. So that again is the probability of KK, and that is 2 over 12 because it occurs twice over a total of 12. So that's 1 over 6. And then we just have what is the probability of selecting a K and a C. So it doesn't matter what order it is, a K and a C together. It doesn't matter the order of the K and the C. So we have a K and a C here, a K and a C here, a K and a C here, and a K and a C here. So there's 4 of those. So it's a probability of K and C. So that is 4 over 12, which equals 1 over 3 as our fraction. And that is it.